All right, so several announcements. We have a quiz. Oh, it's showing up on the back. Good. We do have a quiz tomorrow, and it's on constant rate of change and how it relates to linear functions. So please make sure that you are studying with me in class today and in the evening. All right, the test. The testing center, not the testing center anymore, but the place where we're going to take the test is going to be really crowded if we take it Wednesday. So we have the option of taking it Thursday. How many for Wednesday?
What?
How many for Thursday? Okay. Okay. Thursday. Here's the thing. Otherwise, we're really crammed. Like, we're not even sure because there's like 300 students taking this test over the 2 days. So we're going to take it Thursday. I'll put it on the calendar, but except for that, everything's the same. Same time, same place. Yes. Okay. All right, and I will put it on the announcements as soon as class is over. Alex.
The time of it again?
It is on the blackboard. It is 6 to 9. The location, if anyone's been here for several years, it used to be called the Testing Center. It is in the basement of Wexler. It's a big lecture thing. I will be there. You do not need all 3 hours to take the test, but we want you to not feel rushed. Okay, I know you feel rushed in the quizzes, and that's kind of inevitable. So you come whenever you want, you leave whenever you want, but you have to get there by like 8:15 because you shouldn't take it in less than 45 minutes. Okay? Yes.
So for the people that have work and since it's so short notice, I can't take it off.
But you can. Can you do Wednesday?
I can do it. So are
Okay,
we
come and talk to me.
Oh.
No, I will make an accommodation if you can't make it.
Okay.
Yeah.
It's 'cause
No,
it's
definitely
so
come talk
last
to me.
minute.
I understand. No, we will make it. Are you the one that emailed me? And I will talk to you after class as well. Okay? All right, and the last thing is I'm almost done finally getting all the videos together, so they will be up by tonight if anyone wants to look at them. Okay, so let's start with practicing. We're just going to do a lot of practice today with constant rate of change. And actually, we're going to start with, I'm going to do one problem before we do the one we did yesterday. Okay. So, when you're doing these problems, I want you to think about changes. What's the problem asking? Draw a picture for yourself if you want. Draw a graph. And write your answer in an open expression. Go. So I thought about what you asked me. I really want you to see, I know you're already good at algebraic manipulation, right? And so we don't need to try. Sorry. I always say yesterday for the previous.
Sorry, I was like
Yeah. So I want you to try to do it our way and then check with your way. Okay? That way you're really building it up and it's not based on a memorized formula. But then always check your way and I won't know the difference, right? Alright, talk with your groups, discuss. We're going to try to do a bunch of problems so that you're really ready for a quiz tomorrow. Yes. Did I already email you and said that time?
Well, like I emailed you about the meeting, but since we already scheduled it, I didn't. So we scheduled it like last.
We have to look at it fast.
Okay, let me just come up to you.
But like right when the
Okay, so see the room?
Yeah.
You can use a calculator if you want to give you some kind of comfort, but don't write down the results of your calculator. Write down what you would type in to get the answer. Nobody actually needs a calculator to do any of these. take about 1 more minute. Oh, sorry. That's not what I meant to push. It's coming back. Come on. Can you raise your hand if you feel you have an answer? No one wants to raise their hand because they think I'll call on them. All right, so I'm going to go over the answer. And again, if you're not done, that's all right. I just want to try to get through a bunch of problems, okay? So for this first one, after pulling the plug, the water drained at negative 1.7 gallons per minute. I'm going to go ahead and write for myself. Nope, come on. Go back. I'm going to go ahead and write for myself that means that dy is negative 1.7. I'm still really bad at this, using this thing, dx. So I need to figure out what my change in x is, right? My change in my independent. What is the change in my independent value? So if this is my current x, 6.2 minutes.
Are we supposed to be seeing something on the screen?
Oh no, please don't tell me that. Oh, all right. You have no idea how annoying it is to remake all these videos after I do it once. Okay, so if I have 6.2 minutes right now, then what's my change in minutes from whatever previous moment I'm looking at? 6.2 minus 3.15. All right, there is my change in x. How can I transform my change in x into a change in y? Anybody? If I have my change in x, Corey? Yep. All right, so if this is my change in number of gallons, if I multiply it by negative 1.7, this is now my change in, I'm so sorry, the original is the change in time. So this is now my change in number of gallons, right? My number of gallons has gone down. All right, and then does that answer my question of how much water will be in this tub 6.2 minutes later? That's my change. So if I have my change and I want my new, what do I need to do? All right, it's always change plus old, right? I have to add 5.2, and this is my now new y. Okay, so you always have to say, I can only use this negative 1.7 to go from one change to another change. Yes?
What did you add 5.2?
Okay, so this represented the change in gallons during that time from 3.15 to 6.2 minutes. So it's a negative number, right? But how much was actually in the tub? Well, it's a change from this. So if I add this, then this subtracts from it and goes down to the new. Thank you for asking. Other people? All right, so if you notice, we had a subtraction to get a change, we multiplied and to get a change in y, then we added. So let's now do this next one. Can everyone, I'm going to give you a little less time because we started it. See what you can do for how tall was my weekend before the week. How tall was my lawn before the weekend? write down an expression. And 3 Okay, let's go over it. So this 0.15 inches of growth per inches of rain means that's the difference. That is the multiplicative comparison between the changes, right? All right, so what is the change in my rain? Oh, interesting. I'm going to do it 3 and then I'm going to come back to that. Okay, so there's 2 ways of doing it, guys, right? We can look at it as going initial. Let's imagine this being time. You can say this is the initial moment and this is the final moment. Or you can think of it going backwards in time, which is perfectly legitimate to do. So I can do it both ways. Which way would you guys like me to do first? Going forwards in time, but we're trying to figure out the initial, or going backwards in time, and therefore we're trying to find the final? All right, I'm going to go forwards in time. So that means that my change in x is 3. Notice, I don't always have to have a subtraction, right? Because in this case, I just gave you the change. So you can't formulate it as must always subtract or anything like that. If I multiply this by 0.15, what do I get? I get that 0.45, which is my change in y. All right. Now, in this case, this is how much it increased to get to 2.47, right? So you can do a couple of things. You can write, I can say my this plus my initial y equals 2.47, and then you can solve that and you'll still get an expression, right? Or you can just say, oh, so then if I end at 2.47 and it changed this much, I must subtract all of this. I must subtract all of that in order to figure out where I started. 0.15 times 3. This will give me my initial y, or my initial height of my lawn before the weekend. You could have also done it backwards, where you would have simply said then, the change is -3, right? And then this would have been 0.15 times -3 plus the initial, but isn't negative this plus this the time is this minus this, right? So it works either way. It only depends on how you envision the situation. Questions about that one? Do not think because it's a change you need to do a subtraction. It has to be meaningful. Here I said the change is you got 3 inches of rain, so no subtraction necessary to get the change in x. All right. Here's the next one. Go. and then you can ask me.
So strange.
Yes.
Any more questions?
That's our
Oh, that's what's divided by 4. So what that represents is already, by writing over 4.
I
Is that
have.
writing plus 2 already represents 1? Writing over 4 already represents the daily here, because if you type that into calculator, you got an answer, that would be the daily.
It's like
So by writing over 4, you already represented All right, so the constant rate of change, what is that rate? We can use several things to represent that. You can use an M. I'll often use the acronym constant rate of change, CROC, but either way, it is the change in Y and the change over the change in X. What is the change in Y? There you go. But guys, why are you subtracting 8.34 minus 11.45? I thought you always subtract big from small. Wonderful, because it's calculus. Because we don't do big minus small, you do final minus initial. All divided by, now why isn't there a subtraction at the bottom? Isn't it y2 minus y1 over x2 minus x1? The 4 is the result of that subtraction, right? It's like I already did that subtraction for you and then found 4 and gave it to you. There you go. That is how much it grows in grams per day, right? It's not two separate things, guys. This represents the result of doing this calculation. And that is the daily rate of how many grams. And it will be negative because, as you see, in 4 days, the heat lamp made it shrink, right? Made some of it die off. Great. All right, my car is accelerating at this rate. My speed has changed from 17 meters per second to 2 meters per second. How much time did that take? I have a challenge for you. Do this without writing the variable and solving. You can, but you should be able to think about 2 rates of change, right? There should be a rate of change of meters with respect to seconds, and there should be a rate of change of seconds with respect to meters. So do this without putting a variable. And then you can do it that way too to check. I know you can. The hint is, if it's going negative 3.73 meters per second, how many seconds per meter is it going? And that will help you solve the entire equation. Oh, my goodness. Yes. If this confused anybody, I'm very sorry. There. How many people have found a way to answer this without writing a variable? To be able to think about it with the other variable. I saw a couple of half hands. I'll do it both ways. Okay? All right, so let me say if the car is accelerating at, if the constant rate of change of y with respect to x, or rather let me say distance with respect to time is negative 3.73 meters per second squared, then what is the constant rate of change of t, oh sorry, oh my goodness, why am I writing d, it's velocity. What is the constant rate of change of time with respect to velocity? If the change in velocity is always negative 3.73 times as much as the change in time, then the change in time must be, wonderful, must be 1 over negative 3.73. Right? So then I can say, oh, well, if I want to find the change in time, I just have to take the change in velocity and multiply it by this. What's the change in velocity? 2 minus 17 because it decreased, final minus initial. There's my change in time. And what do I do to get the change in velocity? I'm sorry, my goodness, change in velocity. What do I do to get the change in time? Multiply it by that constant rate of change. Okay? Can somebody please give me an actual number for what that is? Oh, not two negatives, not two negatives. 3, 4, 5, 6. Only one negative, otherwise it becomes positive. Yes, Tom, how much is that? 4.021. All right, so now what I'm going to do is I'm going to do the same thing if you wanted to use a variable, which is fine. I just wanted to get used to the fact that there's two constant rate of change here. Okay, 4.216 did you say? 4.012. All right, so let's put that up here. 4.012. And what if you wanted to do it with the variables? No. Go back.
I'm sorry, it's 4.021.
No problem. Oh. Come on. No. That is so annoying. 4.012? 221. All right. What if instead I said, oh, all right, well, I don't know what my change in x is, but I do know that once I have that change in x, I'll multiply it by negative 3.73. What else can I do? So how will I represent that change in x, by the way? What could I put into this parentheses? You can't do that because that's the change in the velocity, right? But we're looking for the change in time. So what variable should I write down? dx. Or dt. We can use dt. All right. So if this is dt, then this is what representing? My change in velocity. So what should I do now? What should I add to this situation? If I add that to my old velocity, what should I get? My new velocity. Right? And if you solve that, look what happens. You subtract 17 from both sides, so you get 2 minus 17, and then you divide by negative 3.73, it gets us the exact same answer, right? So you can either think about it as, oh, there's two constant rate of changes, and I can go from one to another, or you can write a variable for yourself and solve using algebra. All right, let's do this one. Take a couple of minutes, and we think we have like 2 more problems, and we're going to do something else. I want to see everybody yell out your answer. 1, 2, 3. I have a lot of 38 times 75. Who agrees? Raise your hand if you got 38 times 75. All right. Not everyone has raised their hands. Raise your hand if you have something different. All right, Tom, go ahead.
We came to the conclusion that we had no answer based on insufficient information.
And why is it insufficient? You got a number, you got a array,
They
D equals
never
RT.
gave us- They
Go ahead.
gave us the rate of change, but they never gave us a final or initial.
What you have done, if you wrote 38 times 75, is you assumed at 0 degrees Fahrenheit, what? There's 0 people, so that then when you increase from 0 to 75, you increase 38 times 75, right? But there is no guarantee that there are exactly 0 people when it is 0 degrees Fahrenheit. Not enough info. Not enough info. And why? Someone said we didn't get an initial or final, but I could have given you some information in order to get an initial or final. Can anyone make his answer just a little more precise? What is not available in this problem that says you can't do it? This is a constant rate of change. What is this? A final or just a total, right? Constant rate of change can only go from one change to another change. You cannot multiply it by total unless I had given you like a y equals mx plus b. All right, I think there's one more. How many more are there? Oh, yep, one more. All right, let's go. Cricket chirps. How hot is it when they chirp at 32 chirps per minute? Make sure that you're doing every problem and writing down an answer so I can see you writing as I walk down. Okay? Oh, of course, of course. Whatever you do. Okay, let's think about what this rate means. So let me ask you, am I trying to ask you for, thank you. Am I trying to ask you for the initial independent or final independent or initial dependent or final dependent? Which one? I'm asking you for the final independent. Why? Because if you look at the rate of change, it's chirps per minute per degree Celsius, right? And then I'm asking you for the new final independent. Do you guys prefer when I use the constant rate of change going from dy to dx, or would you prefer that I write a variable? I hear nothing. All right, so I'm going to do this. 1 over 5.6 come on, it really doesn't like to do that, is how much I need to do my change in fact, I'm going to just go ahead and put chirps. Let's see. I have to multiply the change in temperature by 5.6 to get the chirps per minute, so I need to multiply the change in chirps to get the change in temperature. This isn't very good notation, but sometimes the X and the Y are a little confusing. Yeah, you still can't see, can you? Oh, now I'm getting it. I'm always clicking freeze twice, and it's always only getting one of them. I got it now. Okay. All right. Are you kidding me? Yes. All right. Okay. So let's look at the change in chirps. What is my change in chirps? As I'm going, I like to always go in the direction so that my answer is always final. That way I always know I have to add the initial. So I need to go from my initial situation to my final situation. What's my change in chirps per minute? 32 minus 70.1. Wonderful. That's my change in chirps. How can I find my change in temperature? There you go. So if this is my D chirps, then when I multiply by 1 over 5.6, that's my, D temperature. So how can I find how hot it is? Add my old temperature, right? Temp initial, and that must give me my temp final. Wonderful. If you wrote a variable for the temperature and went in the other direction, you should still end up getting the exact same expression.
Why did you do 1 over 5.6?
Sure. So this 5.6 is chirps per Celsius. So that says that the change in chirps is always 5 times as large as the change in temperature. So therefore, the change in temperature must always be 1 over, right? It's the same thing as if I'm twice as big as you, you're half as big as me. Thank you for asking. Other questions? All right, then let's do this before we move on. What if I asked you, how hot is it when, how hot is it when the crickets chirp, X chirps per minute? Can you please define a Y variable, define an X variable, and then write an equation? Go. I'll give you a hint. It should be really easy. It'll cause almost no extra work beyond what we were doing. Can someone tell me what we've defined our Y variable to be?
Chirps per minute.
Actually, see how it says X chirps per minute? So then that has to be the X. Does that make sense? All right, so X is going to be chirps, number of chirps per minute. And therefore, what does Y have to be? Temperature in degrees Celsius. Both times I have units. All right, so now you want to imagine going to a final X of X, right? And that's the only difference. You just don't know what it is. But still, guys, if we go to X chirps per minute, what's my change in chirps per minute? X minus 70.1, right? Here is my X final. Here is my X initial. Here is my change in X. What can I do after that? Multiply by that 1 over 5.6. And once I've multiplied by that, that gives me my, that's really annoying. That gives me my what? Change in Y. All right, but I didn't want a change in temperature. I wanted how hot it is. So what should I do? Add the original. Add the 24, which was my initial, and that will give me my, and now there's our equation for the entire line, right? The equation that describes what happens at any chirps per minute. I would plug chirps per minute into here, and whatever came out would be my estimate of the temperature, okay? Do you see, when you start writing with the open expressions, then there's no new thinking to get to algebra. It's already there. You just cross out a number and hit X there, right?
Instead of Y, should we do Y final?
So usually what we do is Y final is kind of what we're looking for, right? So I would leave it as Y because I'm not looking for one specific one, but it almost is more a matter of convention. Like it kind of is YF, and I wouldn't mark you off if you put YF.
I'm just wondering, just so that it's like equal on both.
Right. So let me put it this way. On the test, I know that because we wrote it as a group, it says Y, not YF, so be aware that you can write it both ways. If you're ever doing a quiz or homework and you write YF, I won't mark it wrong. That's right. Okay. All right. As usual, not enough time. All right, so everyone, how many variables and parameters do we use when we're doing these problems? Write them down by symbol and name, and I'll give you a hint. There are 7. There are 7 different variables and parameters that you use in these problems. Alright, so here they are. And you should be able to circle all these parts just like I did in some of the other ones. Unfreeze both. Good. Alright. Right? There's X initial, there's Y, there's X final, and there's the change in X. There's the initial dependent value, there's a final dependent value, and there's the change in the dependent value. And then, what is the letter that you've always been taught to use for constant rate of change? M. Right? And you can use any other letter for it. So now, can you guys tell me what is our symbol, what is our equation for always finding the Y final of anything? What do we start with? Yes, Charles. All right, so we're going to take that M and we're going to multiply it by what? X final minus X initial, right? Because even though I don't write dx, come on, dx is really right here, dx. And what else do I already have up there, even though I haven't written it? No, what I already have up there? What is already represented up there? dy. And what's dy? This whole thing, right? That's dy. As soon as I multiply by the rate of change and have the dy, and then I add my y initial, okay? And that's called, I think, the point slope form.
Wouldn't it be 1 over m? That's what we've been using for.
It's 1 over m because I gave you the rate of change of x with respect to y, and then we found y with respect to x,
Okay.
right? So you always look at with the constant rate of change. Was it y with respect to x, or was it x with respect to y, and you need to change? Okay, so when I taught high school for 5 years, I completely skipped this section of the book because I was like, y equals mx plus b works for everything. What I didn't realize is, by doing that, I gave my students even more encouragement to only think about totals and never think about changes, right? Because changes are nowhere in y equals mx plus b. We need to be able to think about both of them. So make sure that you understand that because I will have a question like that on the quiz. No, don't leave. I have 2 more minutes. Please answer the online question I emailed you. Right, everybody. A second time, because I'm going to ask you on the quiz tomorrow. So, just for your last 2 minutes, go back to that email, answer it again. Remember that one question that says, what is the constant rate of change of 4.2 mean? And as soon as that we're done, you may leave. Everyone was here today. Wonderful. I have office hours right now. Bring your homework, bring your quizzes, talk to me. No, it's at me. Oh, I never just write on scrap of paper.
Can I have a
If you didn't, if you still can't find that email, then you can just have a scrap of paper and you can write it. Scrap of paper, the right translation. Yeah, I literally just want you to answer it again. You be very specific. Oh, the question's on the thing, isn't it? Oh. Yes. All right, I'm putting the question up for those that are writing on a piece of scrap paper. Open day 12. Here it is. It was, what day is it of the week, really? It's Monday. Oh my goodness. It was on Friday. Does anyone need a piece of paper? Yeah. I want everyone to do it again to see if their explanation is different. And please put your student ID on it when you hand it in to me. That way you get credit. It was sent at about 11 a.m. I'm sorry. I'm sorry. Student study session today. Teacher study session tomorrow. Office hours today. Office hours Wednesday. Test Thursday.
Yeah, it doesn't have to do with email. I've asked me what
You said that have a wonderful day, everybody. Is there anybody else that can?
Thanks. Sorry, I just. Thank you.
So,
I appreciate it.
can you come to office hours now? Or you don't have to? No. Alright, so what I wanted in words here, how do you know, is just what you do here. Right?
I thought I was right the rate of the 8 million and 8 million then.
Because it didn't ask you for rate, nothing about rate.
Yeah. All information about the quiz real fast.
Okay.
So I noticed you circled the word this in my answers that I want to know, like,
That's just looking at word.
they're like this. I can show
Oh,
you.
yes, please, please. Okay. Yes.
What kind of other versions?
Can you just hang on a second?
Yeah.
I don't want a bunch of people to come Wednesday, just come Wednesday and be honest and don't help.
Okay, so for the exam, what should we do?
Just come Wednesday.
Okay.
I won't be there, but it'll be exactly the same test and everything. And, you know, be honest and.
Okay. Thank
I have
you.
the same thing.
Yeah.
Be honest.
Yeah.
Yeah. I'll take you Wednesday. I won't be there. Or maybe I'll try to be there just at the beginning. They won't recognize you, so have your ID.
Yeah.
It's you and it's the same test. Just done another class.
Then I can sit on Wednesday for this.
Let me just check that it's on my calendar. Okay? If anyone else needs to give me that, thank you.
Yes.
Calendar. Thank you. Thank you. Yes, 11:45 on Wednesday. Right? Wonderful. Good.
So this is it, and
Just because, like, remember how I gave you that function and then returned it and we're like, well, how do you call it a function or not a function? You have to be really like, there's always A is a function of B or B is a function of A. So that's why you got the half points out of those 6 points off. You need to be very precise. Blah is a function of blah,
okay.
or blah is not a function of blah.
Okay, even though like after I explained it, or do you just want me just to do just
Well,
this
see,
part?
But if you were thinking about this question, this would be right, but if you were thinking about that direction, it would be wrong. You see?
Oh, I see.
Right? That's why I need to be real specific.
Okay.
Last Thursday night at 7:30. Do you think I could try to leave early?
If you want.
Okay.
Then, if you finish at 7:30, it's an hour.
Tutor before.
Any help? Anxiety.
Okay. Okay. Thank you. I think so. Thank you so much. All right.
So, like, if we don't know the like it's written like the answer why, like, we just get the like amount that we guess, and I want to say that like cause like this we just use it like yeah.
And that's why, so what you do right here, if the axes are the same, draw the vertical and horizontal, and try to know the rate of exponent. Right, right. See, so this part is, this first sentence correct, but then you didn't answer the question, because the question says, try to know the rate of x coordinate and y coordinate.
And then
What does that
we
mean?
explain like 14 points like it's
Okay, I think this is the problem. Okay. See, that's not the rate. That's just the size. A rate has to be how fast something's going with respect to something else. Like speed is a rate, but distance isn't a rate. So I think it's an English language issue.
ratio.
Okay.
Rate.
Ratio and rate, I know they sound alike. They're in English. They're very separate. So I can make an accommodation for that because of the English issues. Okay. But you have to say you have to know like the.
Like we just like it's not correct, but like we're doing kind of find a ratio between the x and y.
Right. Okay. So here, hold on. Let me go back to him and come back.
I did not get an email reading about the like minutes, and I don't know if I should
Okay.
about like because I can do it straight after. Let's see.
You can't do it Wednesday or Thursday.
I can do like earlier and Wednesday.
Are you the one that doesn't want to walk home?
Yeah.
That's understandable. How about you take it with Chanel Wednesday during my office hours, 11:45.
Your office hours?
Yeah.
Yeah, I can do that.
Okay. So I'm gonna expect edit Chanel and Corey to come then.
All right. Thank
Okay.
you.
So don't forget, it's right after class Wednesday.
Okay. Gotcha.
And then for this one, what is
Oh. The only thing is you didn't say how the y got. You know, you just have to you have to plug it into that function is all. Right. To say like how did these come about? Just because when I ask you to explain something in words, I want it to be very, very precise.
So I should say the graph is equal to the x comma and then
So how do you made by points of functions, right? So all of this is right, but you didn't say where these come from.
so I should
Just
say
say
like
because you plug in an x, you get a y, and then you go to the next little spot, pixel on the computer screen, plug in the x and get the y and repeat. Okay, so this one, see, you gave me this, but you didn't. That's how much bigger this is than this. But look what the question asks: how are the x coordinate and the y coordinate represented? Okay, so it's a much simpler question than you answered. You just need to make sure to answer. Okay, we'll just write on this. Okay, so look at this point H. Okay, how is the x coordinate represented on the graph? How is the x coordinate on the graph?
like that.
No, where is it represented physically? Right, that's the x coordinate.
Okay.
Okay, so it's distance to the right of the y-axis. Why? Because that's supposed to be negative. Okay, and now where's the y coordinate represented? Distance above.
Distance vertical.
Right. Yep. So horizontal distance to the right and vertical distance above. Remember I wrote that on the online homework solutions? If you're very upset, I still think that you were doing amazingly well in the class. You are. I know that the English language questions are hard, and I will make accommodations for it, okay? But you need to really very carefully, you told me this is the ratio of them and not what they are independently. As long as you understand it, that it's this and this, then you're good. Can you tell me now again to practice? So, what represents the x-coordinate on a graph?
X coordinate distance from y-axis as a horizontal line.
Distance from y-axis in which direction?
Y coordinate.
No, x-coordinate. Distance from the y-axis in which direction? You want to tell me a direction and then that's positive, so if it's in the other direction, it's negative.
So go to the right is the positive
So-
and then left is negative.
So the distance to the right of the y-axis, right? Okay, now you tell me what represents the y-coordinate?
So distance from the x-axis in a vertical line, and then if it is go up, it is positive, and then go down.
So you don't say if it's up, it's positive, if it's down, it's negative. You merely